So the title of this was very bold, how biology solves pretty much anything. We will try to live up to that, but cut us some slack if we don't, and then we'll have time for some challenging questions from your end. Who here in the room can explain what synthetic biology is? Yeah, that's right. I work in the space for 10 years, and I cannot do it really. So, but I can tell you what it basically relates to as a way of, as an engineering discipline, basically. And I went to our festival website and looked at the different tracks that we had. One is Web3, which is completely tied together with synthetic biology. There's a whole Web3 flavor called decentralized science. You might have seen that already here yesterday, today, or we'll see it in the upcoming days. That ties together blockchain technology with biological research. Then another track of the conference is AI, which just is everywhere really. We will also, I think, hear it from our panels. So this is clearly also a technology that enables biological research and product and service development. Then we have climate, which again, we work with nature as a technology, and nature is the only entity on the planet that has managed a circular economy, basically, where every carbon that ends somewhere in the atmosphere is fed back into some other compound, basically. And this is also what we actively try to do in this discipline. The next track that I saw is health. Again, obviously, as you work with biology, as you work with human cells, animal cells, you gain so much knowledge about this entire space that you will find the best solutions for diseases and different shortcomings in nature, and you can find those with synthetic biology. And then the last track is business success. And then I was like, okay, it's hard to find synthetic biology and connect this somehow to business success. And what I think we're also here for today is to prove to you guys and maybe to ourselves that we think that really hardcore science using nature as a technology can lead to super interesting products, basically. And it's honestly crazy what synthetic biology has given us that you probably don't know about, but you can already buy it. I brought some examples here. Did any one of you ever fasting week or something? So we all want to get into ketosis. This Synbio powder puts you into ketosis immediately, so you don't have to fast anymore. This is all from my bathroom. This is a rejuvenation serum that contains a compound that was previously extracted from shark liver. Now they make it in yeast cells, so you can buy that, basically. I love it. What else do I have? This is my shampoo that contains spider silk protein that makes the hair nice and silky. The protein was first produced in bacteria at a TU Munich spin-off. Now you get it at the Body Shop. And this is maybe the craziest one. These are basically genetically modified bacteria that have an enzyme that will help you avoid a hangover. And I don't only want to preach, I also want to drink the Kool-Aid. If you want to, let's all have this before we...
No, this is a perfect preparation for tonight. Thank you.
I think it is, so cheers, let's have this. Cheers. Cheers, you guys. Lovely.
Tastes like bacteria.
So that kicks off the gospel of synthetic biology. Maybe we start with a brief intro round. Yeah, you can tell I have a vested interest in the space. I worked in SynBio in the academic space for a couple of years, then shifted gears and became a startup founder and operator in different startups for a couple of years. And then after some angel investing and so on, I joined a fund called Amino Collective. That's a Berlin-based health and bio fund. We do pre-seed and seed stage investments. We love synthetic biology. We all love everything that happens on the software end that enables biology. We love healthcare solutions. We love hardcore biomanufacturing. Yeah, I guess we cover all of these spaces. Again, all of the tracks that you hear here at Tor about, we have that. There's Web3, we invested in a company called Molecule. You'll be able to see Paul Kohlhaas on stage tomorrow. He's in that space. AI, again, pretty much in every company out there. Climate, kind of similar. Health, different ones. We have Kano Therapeutics in our portfolio. They build cool RNA and DNA solutions for all sorts of novel therapeutics. But we also have this expertise here on stage. When we talk about climate, I think about this guy, Mitch, and his company, Cambrium Bio. When I think about health, I think about the very crazy things that Dani builds at Yuri. And I'd love to give the two of you the chance now to talk a little bit about what you're doing, why you are largely working in the world of atoms rather than bits, and how this is going to affect our lives in the very near future. Maybe Dani, you want to kick it off?
So, hi, I'm Dani, and I'm working at Yuri, which is a commercial space biotech company. And what we have been the last 3 years, we did science as a service, bring experiments to the space station, and we learned a lot. And the very interesting is that we understand that some things in microgravity conditions are different. It's a complete new world, a complete new extremophile site, where microorganism and production metabolism is different. And they're actually where we think we can bring a complete new world for life science and health, and just make things possible which have been impossible so far.
Very cool. So you're working in space, and we're working down here on the ground, working with materials. And so he had alluded to climate tech. I'm Mitchell Duffy, and I started out collecting fossils as a kid, got really interested in biology, and felt for a long time that I was born in the wrong century. I really wanted to, go out on expeditions and learn all about a whole bunch of different animals that had never existed before, but it was all kind of discovered. And then I learned you can actually, modify cells. You can change the way that they work, and that took on a whole new fascination for me. And so I've set out throughout my career to basically create cells that produce the things that we use every day. And we are looking to address 23% of greenhouse gas emissions and the untold externalities that come from the material world around us. And I think as he had shown you today, there are many things that can be made from synthetic biology. But if we even just look at the materials that biology makes today, basically everything you're wearing could be made from biology, and previously was. Most of the products that we would use for skincare definitely were. And I think we can go back to that while still having increased performance. So that's why we founded Cambrium, and I'm pretty excited to speak about it today.
So I want to continue there. Cambrium launched a first product quite recently, very much in record time. So you produce human collagen, but you don't collect it from humans. You actually make it in a bioreactor, in a stainless steel tank. So why? And what do we need collagen for?
So collagen makes up basically 80% of the protein that you create. It's your skin, it's your bones, it's your teeth, actually. And we were focused on it because there was a call from the cosmetics industry to use collagen in a vegan way. Currently, if you want to make it, you take the remains of animals, usually the skin, dry them out, mill it, boil it in acid, and then put it into the creams that you use for anti-aging, or into your Haribo gummies or whatever you might use it for. So instead, we said, let's see if we can make this in a more sustainable way. And so we are able to create it in a bioreactor in yeast, pretty much the same way that you brew beer. And then we go through, instead of a distillation process, we have just a kind of a filtration process, and bam, we have human collagen that can be applied to your skin. Why human, right? It sounds a little creepy. In the end, this is how we can speak with your body. So if you're going to give somebody insulin, you would want something that is very similar to what the language your body speaks. And so what we can do is speak the language of your body better than the porcine collagen or the bovine collagen from cows and pigs that people use today. The way our product works is it's a particular subsegment of the collagen that makes up most of your skin, and it kind of tricks your body into thinking it's broken down too much. And so it starts to repair even when you would normally be at homeostasis. So it's like wound healing, really, but for your skin, even when it's healthy.
Dani, I sort of looked up the location of your labs, basically, and I thought there's one that's somewhat close, and there's another one that's very far away, but I actually got it wrong, because one of your labs is in Barcelona, which is about 1,500 kilometers, and the other one is on the International Space Station, which is at the right point in time only 400 kilometers away, so it's actually closer. Why experiments in space to solve very tangible problems on Earth? So now we heard from Mitch, there's a good reason to make human collagen, there's a good reason to make it in a different way than it was sourced previously. What are the problems that you are solving, and why do they have to be solved in space?
So we always, whenever you look in the biochemistry, technology, industries, wherever you're going, you always see everything is run and produced by enzymes, and productions have been run by enzymes. And most of these enzymes have been collected in extremophile sites, for example, in the deep sea, on the mountains. But at some point, we get some point where we can, today with AI technology, we can see that these species or these proteins, they can actually do more. And why they're not doing it? But then, in the last 15 years, International Space Station, we can see them. We can see the missing products, which we know they can do it. We can see increased kinetics. We can see higher thermostability. We can see, which leads to longer shelf life of products. We can see bacteria suddenly is able to survive toxic waste. It means we can degrade and do some environment. All these missing links. And why? Because now as a space station, we don't have physical constraints, for example, sedimentation and convection. So what is convection? Let's be all a bacteria, right? So you're all breathing, so also please continue breathing. And when you're breathing oxygen in, right, you're breathing carbon dioxide out. And to convection, gases are different to the gravity, so carbon dioxide falls down and oxygen comes in, so you constantly have fresh oxygen in front of your mouth. But in space, there's nothing, not like this thing. So an astronaut is breathing out and all the carbon dioxide stays around your head in a bubble and you die, and hypoxia, because there's no oxygen, and nobody on Earth understands why, because there's oxygen on the ISS. So as a bacteria, you have the same problems. You can't just get to the surface and build biofilms. You can't just get to oxygen. So what you do? You have to survive, so you adapt. to something new, which has always have been imprinted in your DNA, or little mutation would bring you there, and then you can see it, sequence it, learn it, and implement it in our daily healthcare life science. And so you finally can really get the whole spectrum of biology possible.
So you collect information basically and physical new bacterial strains or whatever it is that has changes that wouldn't have occurred on Earth basically. Then a question to the two of you, who do you then sell this to? And why does that create additional value for your customers? Because in the end, I think what we want is, more of this stuff. This is super niche now, but we basically want to transform the entire physical space around us and make it all bio-based. So in order to do that, we need to follow some written or unwritten rules of the market, basically. How do you solve that, and why do your customers come to you?
I can start first. So maybe you all remember there was this COVID pandemic, right? And you all these tests, which is a PCR test. So there's a polymerase, an enzyme, which apparently takes quite a long time. So we can have products, the same enzyme just works 4 times faster. So actually you could have your result not like in 1 hour, 2 hours, but in 10 minutes. And these enzymes in literally everything, just about cheese industry, like laundry industry. Suddenly you can wash your clothes at like room temperature, the same efficiency, like 90 degrees. You don't have to put your medicine into the fridge anymore because it's thermostable. And you can look also even in the pigment industry, cosmetic, right? You see suddenly pigments, out of space blue. We just identified out of space blue, which is mind-blowing. So really, or we got just like macromolecules, a bacteria which is supposed to be small like a dot, got huge. We called it caviar bacteria. No idea why. But this little alien bug have a membrane outer it, which could solve toxin levels. You could increase the yield to 90%. There's literally no industry we're not touching. So many opportunities, and we're really looking forward to the next years.
Super cool.
Mitch? So we sell to brands, brands that make cosmetics. We don't sell to the ordinary yet, but I say yet. So, and I think that's for our cosmetic products. Then we are looking toward further products in fashion, and there we need to integrate into the right part of the value chain. So we'll be working with different people who make materials, providing them with proteins as hero ingredients for their materials. So I'll give you an example. We're sitting here on what I presume to be pleather, but we can assume that it's leather, and even if it's genuine leather, it's up to 20% polyurethane, up to 20% plastic. And what we can do is to create coatings that don't have plastic in them but are instead made of protein. Turns out that proteins were used for plastics before petrochemicals came along. A plastic is just a definition, and there were many protein plastics that were used. Even some of the first Ford cars were made from soy protein plastics. So if you could take that soy protein plastic and upgrade it so that it's not, so brittle, or you basically can upgrade its material properties, then we could bring back biomaterials that are much better for the environment, can break down, and we don't have to use as much petrochemicals. One of the things that I think people don't think about is the way that the market props up the polluting industries such as the oil industry or the meat industry with byproducts. So for instance, with collagen, it's the meat price is helped and maintained at a low price because they can sell the byproducts like the skin and the bones to somebody who's going to use them for other purposes like cosmetics. If we can remove that, then we would jack up the price of meat and maybe more people would switch to alternatives. In the same way, as people have moved toward renewable energy, then the oil companies are forced to move more and more of their flux of oil into materials, which is the reason why we're seeing a skyrocketing use of plastics today. So if we can address these market forces by bringing in powerful alternatives, then I think we can actually see a change in the way that we consume products.
We are getting close to our time. Maybe a final question with short answers. What are you mostly excited about coming out of this industry within the next 2 years? Not 10 years, not like fusion energy or something, but 2 years in biology.
In 2 years, currently we are collected more than 8,000 strains in a couple of days. I hope that we can significantly help healthcare system with pharmaceutical solutions for I really think that we will have an impact in everything in the nutrition industry and drug discovery industry even. But I think the most likely low-hanging fruits right now, in the next 2 years, we're a pharmaceutical company with shelf life, not because this is the easiest one, but this is what we need for everyone. And the second one is low-hanging fruits like cosmetics, blue collar. I mean, literally, I just look for blue collars in space. It's not a big deal. But I think also making things more efficient, more thermostable, and basically more for humanity and just not because it's easy.
Yeah, and you'll have the biggest collection of alien life forms on Earth, probably.
Most likely, yes.
Mitch?
I've been seeing several different people who are producing things through gas fermentation, so basically taking flue gas emissions and directly capturing them and putting them into creating products. And I think that's really exciting, and I think we're going to actually see some things at least demo scale in the next 2 years. So imagine that you're able to make platform chemicals, the things that make up this table or this or that, made from emissions, and having companies actually willing to pay for that because you're able to reduce your emissions and somebody else is able to make a product. I think that would be that'd be great.
Basically turning carbon dioxide in the air into a resource.
Yeah, a feedstock for the future. So
Makes
third
sense.
generation feedstocks.
We're almost out of time. My quick answer for that, I think, is we're getting close to really unlocking crazy things with artificial intelligence in the space of biology. Protein structure, protein-protein interaction, how small molecules bind to proteins, and it all sounds a bit abstract, but this is going to solve so many issues. And then what? Then we need to build all of this stuff in the physical space. So I'm excited about the manufacturing angle. We already invested in different companies that produce physical things to unlock RNA therapeutics, for example, to really allow developments in biology to reach everyone. And this, what we will see over the next 2 years is a growing awareness that we will have to solve these issues in the physical space. There's only so far that we can go with bits. At some point we have to move to atoms. Do we have, I think, yeah?
We have time.
Wrap it up here and open
We have
it
time
to
for one
thought.
question. No slide or questions, so anyone from the audience?
I don't know if you want to take that one instead or go with my question. I have a question for Mitch, actually. Just because it sounds all really cool what you're doing. So I was just wondering how energy efficient is what you're doing? Because like, especially if you kind of like produce or create synthetic plastic or however it's called, how much energy do you need to do that so that it can be sustainable in the long term?
Yeah, so I think in terms of like trying to produce whole plastics, you need to have some other bulk material than, you're not going to precision ferment, which is what we do, the bulk material. You're going to take some bulk material produced in a very sustainable way, and you're going to basically modify it with our proteins as a hero ingredient. We are more like a plasticizer than the bulk plastic. And this allows us to have lower inclusion rates and have less of an effect on the energy. Turns out that if you're trying to make bulk plastic, it's terrible for the environment, but it's super energy efficient. I mean, they have built these things. I mean, Ludwigshafen is massive, and they have economies of scale, and they can burn this stuff for dirt cheap. So competing against that on a like-for-like basis is going to be very difficult. But for instance, if you look at our collagen, it's, you know, the LCAs look like about 90% better than growing a cow for a year, slaughtering it, and then going through all of these drying, milling, and boiling steps. So it kind of depends on who you're competing with and exactly what you're trying to achieve. Thanks for the skin compliment. I will tell my girlfriend, because we actually, when we end up going into the cosmetics arena, she was like, your skin is not good enough. And so what we ended up doing was, I said, okay, let's purchase products together, and then we put it in our Splitwise and split it down the middle. So I use whatever she's using. I often don't know what it is, but it's great, and I'm very thankful to her for that.
Sounds like a good deal for you.
Yeah. So shout out to
And
Olga.
in the future, of course, buy Cambrium skincare products, because the collagen will rejuvenate your skin, obviously.
All right, that's all we have time for. Thank you, three of you. So